Hello and welcome back, and today we are absolutely going to get this TI-99 4 working, and I can say that so confidently because I'll just sit on this intro for as long as it takes. If this machine never gets up and going, this footage will never see the light of day. So if you're watching this, that's awesome news because it means that we got this thing going. So how did we get there? Well, at the current point, I don't actually know because it still doesn't work and we're still in the process of troubleshooting. Now, in the previous episode, I actually caught a little bit of flack for the way I was going about troubleshooting. So let me address some of the concerns that people raised in the comments of the previous episode. And of course, the very first things that I checked were the obvious things that you're supposed to check on any non-booting system. Is the power good? Is the reset signal good? Is the clock good? Or in this case, are the clocks good? Because there's a 4-phase clock going on. Is there data on the data bus? And is there addresses on the address bus? And yes, all 5 of those things are good on this machine, but we still have a non-booting system. So now we need to get a little deeper into the troubleshooting process, and that requires a more intimate knowledge of the system you're trying to troubleshoot, and I'm still learning a lot about the TI-99. To make matters worse, the 99.4 is actually a little different than the 4A, but I did actually find a pretty good troubleshooting procedure right here that is specifically for the 4, and it only ever ends up looping me around to saying replace the LS138 on the side, which of course we replaced with a known good chip, and it still doesn't boot. So the troubleshooting procedure that was supposed to save us didn't save us. And I found a couple other troubleshooting procedures and I followed them along and we still didn't get there. And so we kind of reached an interesting point where I was actually just replacing ICs as opposed to actually following some troubleshooting procedure. And that's because we hit a time management problem. It takes only about 20 minutes to pull an IC, clean the PCB, put a socket in, solder it in, put a known good IC in after that, and test the system. It takes me longer than that just to set up the logic analyzer. And so I caught some flack for that, but I think from a time management standpoint, that was the correct path to go. Now we've hit a point where all of the suspect ICs have been replaced and we still don't have a booting system. So we need to get even deeper into the system, which means now we need to spend some time getting really intimate with our logic analyzer. And I have it set up right now to do just that. I've got it hooked up to the full address bus, the full data bus, and we're looking at the MIM enable pin. So that way we can get a proper look at what addresses and what data is happening when they're supposed to. And we can actually follow along with the console ROMs that are going through the boot process and see where we kind of come off the rails. So let's fire the logic analyzer up, follow along with the actual ROM data, and maybe that'll give us a little bit of insight. So we're gonna get there, I promise. Okay, this is the HP 1630D logic analyzer that I got from John. This is a fantastic tool, and this is what we're gonna use to dig really deep into what's going on. So we have our full 16-bit data bus and address bus hooked up, and we're going to take the clock off the memory enable pin as opposed to the actual CPU clock. So that way we're only looking at valid addresses. So let's set up our format here, and we want to go down here, and we're just going to name this to address, ADD Shift R. And then we want to turn off all of the pods that we're not using. So we'll turn off everything to there, and then we'll skip over to the end of pod 2, and we'll turn off all of those. So that's our address bus. We'll insert another one, and we'll call it DATA here for data. And it's going to be pod 1 and pod 0. So we'll move over to there and we'll just call these pod 1 and pod 0. Now the other thing that we need to check is that there are 3 different clock pins that we can use to clock off of, J, K, and L. I've got it set up to use clock L. So we need to go over to clock L, and we want to get it on the rising edge of that so that way everything has time to stabilize. Now for the trace itself, we want to do a single shot. So we're going to do single here, and we want it to start when A is not equal to 0. And then we're going to store all states. And so we want this to be 0, 0, 0, 0 there. So we want an actual valid address to show up, and then it's going to store every single state after that, even if it is 000. And that should be just about everything. So we'll go ahead and hit list, and we have these set up to hexadecimal, so we'll hit run. It's going to tell me that there is a slow clock. So now all we have to do is turn the power switch of the TI-99 on briefly, and we should get the startup sequence here. So I've been working very closely with Tercy over on the AtariAge forums, and he's been digging through this and disassembling it, and we've been following along with it and the boot ROM, and we can actually see a lot of stuff going on here. Starting at the top here, FE00, this is just junk that's pre-reset. But at number 1 here, we get 0000. This is the reset vector. Then we have an 83FE, 83FC, and 83FA. These are 3 sequential SRAM accesses to save the status register, the program counter, and the workspace pointer. Then we hit the reset vector. We should get 12 off of that, which we do get. And this is a load operation to save the address of the GROM port, and then fetch the immediate data of 9800 and 00160200. This is to save the starting GPL address. Then we do a fetch the immediate data, and it should be 0020, and we can see that that is correct. Then we go to 001A. This is a jump to 0034, which we can see in the next instruction after that. This is a couple of instructions that does a dummy GROM read to reset the address flip-flop. Then we have 0036 with C180. This is a move instruction that prepares to work on GPL addresses, and then we'll go ahead and scroll up here to the next set of 16 instructions. We have 2 SRAM reads that are just getting data out of the SRAM. Then we have a jump to 0060, which we see happens correctly. Then we have 0060 itself being another move operation that is to write the first byte of the address to the GROM. And then we have 0064, which is another move operation. We want to write the second byte from the assumed address of the R6 least significant bit. Then we're all the way down here at 006A 5820. This is going to clear some bits in 837C used by GPL as a status register. So we follow that with a read immediate data of 0047. That's working correctly. So we'll move to the next 16 instructions here. And then we have a read word at 0046. And then we follow that up with a read immediate address 837C. And then we follow that up with an RBW2 837C. And then that brings us up to 00700300. This is to enable interrupts. Then we do a 0072002. This is reading immediate data from 002. And then we disable interrupts, and we want to read the immediate data of 000 after that. And then we're at a move operation to read a GPL instruction byte into R9. Then we do a 007A. This is a starting instruction decode. Then 007C D109 is a move operation. We're going to prepare to work on the instruction bytes. So we follow that up with a read from R9 and an RBW on R4 with 83E8. Then 007E at the very bottom here, 09C4. This is to isolate the top nibbles. So we'll move on along to the next set of 16 here. And then we have an 83E8. This is read R4. An 83E8004. This is an RBW on R4. And everything up to this point has been pinpoint perfect to a booting system. And then it goes off the rails. Everything from this point on is incorrect. So something happens. We should be seeing 0080. There should have been a branch here, but instead we're seeing 0200. So something is not right. We lose the plot at exactly this point. All right, that was a lot to take in. I went through it at a lightning pace, and it was still a lot and quite long. But I did that to illustrate 2 points. The first is just how complex this failure mode is. I absolutely would not have been able to discover where we went off the rails without the help of Tercy. Throughout all of that, I was essentially just reading Tercy's notes. if this machine ever gets up and running, it'll be due to his work, because this is actually quite a bit beyond my capabilities to understand. So Tercy, if you're watching, thank you so much. The second reason that I went through all of that to show you each individual instruction was to illustrate just how deep into the boot process we're getting. There are a ton of successful operations happening before things go off the rails. That means like 99% of the system is working, but we still don't have a booting system. So it's a really complex failure mode, and I think we're starting to hone in on it, because we saw that 0200 showed up when we were expecting 0080. So that 0080, it's just one single bit on the address bus, could potentially have a problem. Now that address line only goes to the SRAM, to the ROMs, and to a little buffer chip for a port, and that's it. So there's not a whole lot on that line, which should hopefully make troubleshooting it easier. Hopefully we come across a fairly obvious break, we can bodge wire it, we can get this thing up and going. But if that doesn't work, we're gonna have to dive right back into the logic analyzer and go again. But we're not gonna quit, because it really feels like we're honing in on the problem here. All right, so based on the disassembly, we know that something hinky is going on with A6 and A8 potentially. So I've actually marked A8 here. That's going to be this one right here. So let's check the resistance between A8 and A7. And that's coming in at 9.5 mega ohms. All right, so let's check between A7 and A6. That's like 27 mega ohms, so there's no connection bridge there, but let's check A8 and A6 to each other, and oh wow, all right, 48 ohms. That would definitely be a problem. That's gonna be a massive problem. Well, I think we might have cracked the case on this one. We got to find out what is causing those two pins to be connected together, but it's not a dead short, which is why we're seeing that kind of weird, inconsistent behavior out of it. It's enough to get essentially crosstalk between the two, but not consistently pull one down or the other. So let's trace down what's causing this connection, and that might just fix this system. Well, I found a problem. These two vias here come from A6 and A8, and they are right up underneath the edge of the socket for the console ROM. This is an original TI socket, and it's an area where I haven't done any rework at all. So I don't think that's my solder. I think that solder has been hidden there for a while. But I mean, it could very well be. It's just in a very strange spot. So regardless of how it got there, let's clean it up, get those two vias properly separated, and plug all the ICs in, and hopefully this gets us to some semblance of booting. All right, here goes nothing. Please work. That is a very different situation. It's not a full boot yet, but it's maybe close. Oh, I can see some life in there. Oh my God, we're almost there. It's not a full boot, but it's close. I can clearly see Texas Instruments in the broken display here, but we're mostly running at this point, so it has mostly booted. If I hit enter, yeah. Oh, we're so close, so close. All right, it's clearly booting. Let's turn it back on. We can see it's trying so hard to display something, but there is a switch on the back of the monitor here that switches it from 75 ohm termination to high impedance. So let's flip that and see what happens. Oh, that's much closer to a real picture. We seem to have a vertical hold problem, so we'll adjust the vertical hold, see if we can get that to stop. Yeah, there we go. It booted. Let's see if we can get it a little brighter here. Our brightness is maxed, so let's bring the contrast up a bit. That's maxed. Wow, it is so dim. Let's play with maybe the color and the tint, perhaps. Okay, there's also a potentiometer on the back of the board here that allows me to adjust intensity, I think. And if I bring it all the way down, it just disappears. And if I crank it all the way over to the right, it's kind of there. But I mean, copyright 1979, Texas Instruments, we're fully booted. If I press a key, yes, press 1 for TI Basic, press 2 for equation calculator. TI Basic ready. This thing is straight up functioning. Let's plug in a cartridge here. Plugging in a cartridge resets it. So if I hit enter, there we go. We've got our cartridge, EasyBug and mini memory. If we go into EasyBug, that's amazing. And it looks like garbage. Everything needs to be adjusted, and there's a huge amount of what looks like interference on there, but that is a working TI-99 4. All right, I've been doing a little tweaking of some of the settings that I can get to on the color monitor here, and I think we got it to a pretty good spot. Before I flip the power switch on, it should be noted that I'm using the original power supply with the 4A power brick, and that seems to be working pretty well. So we'll flip the power switch on here, and you can see that's decently sharp. We still have 3 main issues that need fixing. There's a ton of interference, and I don't really know where that's coming from. The vertical position looks like it's maybe a little too high, but there's not an obvious adjustment for that. And I think we're gonna have to take the back off because we still have a lot of really bad ghosting. But for the most part, it seems to be looking pretty good here. So the system TI-99 4 here actually works. If I press any key to begin, we'll just go ahead and hit the spacebar. Well, the spacebar doesn't work. That's an interesting problem to have, but there is another spacebar key right up here on the left. I don't know why it's there, but they've got it. And then we'll go into TI Basic, and the bigger problem with the keyboard is this. We'll just try to type "the quick brown fox jumps over the lazy dog." Okay, so we have a ton of repeated characters. So either the keys are exceptionally dirty, or they're just not very good, or both. But I think we need to try and maybe get all of the keycaps off and try to get some contact cleaner or something in there. And then hopefully that can get rid of some of our repeated characters here. But it's pretty much a usable working system at this point, and that's pretty epic. Let's see if we can get it to the rest of the way to the finish line. And here we are, TI-99 4, all back together in the middle of our 5-foot long TI-99 train, hooked up to our color monitor and currently on and running. A point that I did not think I would be able to get to just last week. And honestly, I would not have been able to get there without the help of some very smart people. Tercy, Dan, Greg, everybody over on the AtariAge forums, everybody in the TI-99 Zoom group, you guys helped tremendously with this build. I don't think I could have gotten there myself. It's a really simple fault. We just had a little piece of solder that had gotten wedged underneath a socket, and it was creating a low resistance short between 2 vias. Now, whether that solder came from me or somebody else, I don't really know, but it doesn't matter because here it is fully working. Kind of. There's still some things that need doing. The spacebar here doesn't work. It's a separate key switch all unto itself, and I think I'm just gonna need to replace that key switch. However, there is another space button. It's just over here on the left. So I just gotta retrain my brain to press space with my left pinky as opposed to my thumb, and then we can continue using the system like normal. Also, there's still a ton of noise in our video signal. It's decently clean, but we still have that ghosting problem and we still have the noise. Now, the ghosting problem shows up on whatever I plug into the monitor. So that, I think, is related to the monitor itself. But the noise is only showing up when the 99.4 is plugged into the monitor. The 4A doesn't have that noise problem. So there's still something not quite right in the analog video circuitry of the 99.4 here. So we're gonna have to take it apart in the future and dive into that. But for now, the system is totally working other than that. So we can just hit enter here, press 1 for TI Basic. That gets us to TI Basic ready. And then we can just type a short little program. We'll do 10 print hello world 20 go to 10. And then we'll just type in run, hit enter, And there we go. We've got it in an infinite hello loop, and then we can break out of it with Shift-C. This is very similar to Control-C on data terminals, but there we go, fully working TI-99/4, and you may have noticed that the keyboard is working perfectly as well without having double key presses. Spraying that little contact cleaner in there and using the keys a bunch fixed it perfectly. And honestly, the little chiclet keyboard is not as bad to use as I had feared. It's really pretty similar to typing on a teletype. You just have to be very deliberate in how you type. And I think with a little bit of practice, I could get quite used to using it, and I could potentially write some pretty long programs with it. Well, I'm probably not going to do that because the Alps keyboard on the 4A is just such a nicer keyboard. So if I want to sit down and do some serious TI-99 work, I'll just pop this one out, put the 4A in place. But for now, the 4 is definitely going to live in the middle of our complete TI-99 sidecar train. Well, there's a little asterisk on complete there. There's 2 more sidecars that I don't have that I would love to get. One of them is the video controller. They were produced just in very small numbers. The other is the P-code sidecar. And they never produced them, but they made a few prototypes, something like 5. So I think we might be able to make a replica P-code sidecar because it uses just a regular sidecar box. And I have a spare one of these boxes from a spare RS-232 sidecar. So we could use that box, build a custom PCB inside that has all of the P-code stuff on it. And we can even get the P-code GROMs off of one of the cards that goes into the peripheral expansion box because they did produce the P-code for that. So there is some more TI-99 shenanigans that could come. But we are going to take a short break from this system and get into some other stuff. Most notably, we've got some work to do on the CPU-5 Centurion, and we've got a lot of vacuum tube content coming up. I've been doing a complete redesign on the vacuum tube memory/computer that we're building, and I have a secret that I've been holding real close to the chest that I'm quite excited to share with you guys. So if you've been chomping at the bit for some more vacuum tube content, definitely hang around. There's some coming very soon. But I want to thank you guys so much for watching, and I hope to see you in the next episode.